Desk Ladyada.
Hey everybody, and welcome to my desk. It's me, Ladyada, at my desk. Got some electronics going on. I've been working on a bunch of revisions, not as much interesting stuff, but I did get some cool samples this week, so I thought we would do a little bit of a mailbag because I got a Raspberry Pi 5. Yes. Um, New Raspberry Pi. Now you're probably wondering, wait, did you get like 1,000 and I can have one? No, I only got like one. But if you go to the computer, real fast, Mr. Ladyada, thank you. We've got signups available. So we don't do pre-orders because we only ship things that we have physically in stock. We don't want to take your money if we don't actually have something to ship. So what you can do is you can sign up. We will only notify you when they're in stock, and then you can place an order, and your order will ship pretty much immediately because, again, we will only sell them. Oh, Marty, if we actually have them. Okay, so but I did get like one just for me to do some testing with. So let's go to the overhead because I just picked this up on Friday. So thanks to the Raspberry Pi folks to send me one. So this is the Pi 4, and this is the Pi 5. And then this one says Circuit Pi because this was originally this one was used for my Circuit Python test. So a couple things you'll notice. Maybe I'll take these, easier to show them side by side. Big changes are USB ports change direction again. Now they're back to how they were for the Raspberry Pi 3 and before. So these are the Ethernet and these are the USB. We still have two USB 3s and two USB 2s, which makes sense. This is the main chip, new main chip with a nice heat sink on here. Instead of the camera and display connectors over here, they've been changed over to fine pitch versions. So these are 1 mm. Now they're 0.5 mm vertical. We actually talked about these connectors on the Great Search a couple weeks, maybe a couple months ago. If you're interested, this one, is broken. It should look like this. I've replaced. This is my board for testing cameras, so I'm like constantly removing it. It wasn't meant for hundreds of insertion cycles. Other interesting things: the PoE port moved. Used to be over here, which was a little annoying to me because it would bump into hats and bonnets. Thankfully, it's been moved out. That should help reduce the interference. It's also, of course, next to the Ethernet jack, right? That's the most important thing because the Ethernet pins come out here. These are the 4 pins that go into the PoE chip. Maybe RAM here just got moved around a little bit. Power supply chip changed. Now it says dialogue chip. This is very nice. This is a very nice layout. Look at how beautiful that is with like all the inductors in a row. And these are either diodes or pass transistors, not sure which. A beautiful little chip there. We still have the Wi-Fi, Bluetooth. Excuse me, I'm gonna move this. Pardon me. Wi-Fi Bluetooth chip and the trace antenna. New PCIe slot. We talked about that I think last week. I talked about PCIe slot. Another couple extra ports. So this is the battery for the real-time clock. I think this dialogue chip probably has built-in real-time clock support, so it can like sleep, wake, based on a low power battery-powered input. Also, if you don't have internet, it can maintain time and stuff. So this is really going to be really great for low power usage. And then fan and UART as well. I'm just popping off the. You can tell these are like so fresh. They have that fresh, not have the caps removed thing. This little resistor selector here lets you know which version of the RAM you have. I think it's a cute little hack. It's just a random resistor that they're using for some pull down or pull up, but they put silkscreen next to it so they can use it in addition as an indicator to let you know how much RAM it is. Otherwise, you have to boot it up to determine or try to read the part number. The big interesting thing is that they've replaced, this was, it's like a VLI and some BCM, Ethernet PHY, and USB hub. And it's been replaced with, let's see what we got here. This is a still a BCM PHY. I think this is the PHY for the Ethernet, although I'm not 100% sure. And then this is the RP1, which is used as the GPIO and I think USB controller, which is very interesting. So this was apparently the predecessor to the RP2040. I mean, there's so many Raspberry Pis made, and each one of them needs this. Yeah, historically it was a microchip USB hub / Ethernet converter chip, right? I don't remember the part number. But you know, microchip parts are not inexpensive, and maybe they didn't have all the capabilities they want. And I can see why the Raspberry Pi folks were like, well, we want to combine all of the GPIO needs and accessory needs and make one chip. And yes, it'll cost us millions and millions of dollars to develop custom silicon, but it's worth it because we sell millions and millions of Raspberry Pis, and it's like $1 per Pi is totally worth it to not have dependency on chips. And especially since, you know, in the last year or two, in addition to chip shortages, the prices of chips have gone up a lot. I mean, we've had some components that have tripled in price. That would, you know, strongly affect the ability of Raspberry Pi to maintain their price point. For manufacturing, some things that I thought was interesting. Well, first off, you know, the look has just been, it just looks so much more organized now. Not that this isn't, you know, a beautiful board, but the Pi 5, you can tell really a lot of effort was spent, and like everything is like centered, and this is like nice, and everyth's at like the nice angles. And like I said, this power supply is so beautiful. The layout in this this area, and nothing looks like it's, you know, jammed together. It looks very well thought out. And then another interesting thing is the through-hole pads are no longer wave soldered. So you can see here, you know, there's like very heavy solder because this was selective or wave soldered, where it's a secondary process that is used, you know, for the through-hole component here, and then Ethernet and USB. These are all through-hole components. And these are, I don't remember the name of it is, but it's like through-hole in SMT or something. And we use this technique actually quite a bit for our USB ports. Let me show you one. So I've got this micro USB. So this micro USB is a surface mount component, but it has 4 through-hole legs. And what we do is we just have really big pads, have and be a surface mount process. It's placed as surface mount, and then just that extra solder, there's enough solder on the pads that it melts through and gives a very good mechanical connection. So that saves you one process. And wave soldering is very messy, time-consuming, expensive, like labor and repair work. You know, often there's bridges and you have to fix them by hand. So you can see that's why, like, these are like, you can see this really nice Hershey's Kiss, like large solder blobs. And here, you know, everything is connected, but it's not as blobby. It's definitely there. And there's the mechanical supports that you'll notice they have oval slots, and like you want to make them very tight so that when the part goes through, the legs go through, it catches onto that paste that you deposited. Another thing you can do is if you have a multi-step stencil, which is, I've never used one, but I know they exist. You get stencils with different thicknesses. And so what you would do is the stencil over here would be really thick because you'd want an extra deposit of paste. And then when you're here at the BGA components, the paste would be thin again to avoid bridging. So, I mean, but a stencil, even the most expensive stencil, is not going to be, is definitely going to pay off for not having to do, you know, the labor of putting this through the wave solder machine. If you can have this go through just pick and place, I mean, like that is the easiest, least expensive. And this beautiful capacitor array. A bit of junk there, but like really, really nice layout there. And I think, you know, if people have seen the robots, these components are robotically placed as well. So, you know, fully automated, no manual labor required to place it. Okay, so anyways, that's my, you know, initial inspection of the Pi 5. So it's interesting about the Pi 5 that relates to what we do here is that now the GPIO is handled by this RP1, which is very promising because not that having GPIO in the Raspberry Pi was amazing, but it was constrained because you have to have 3.3 volt logic. And as you get to better and better chips, they're not going to be 3.3 volt logic friendly. They're going to be 1.8 volts or 1.3 volts. They may not even have, the ability to set the IO voltage to 3.3, like maybe for I squared C, but they're not going to have general purpose IO that is like, I can source 4 amps, or 4 milliamps to an LED. And they might not be protected. They might be very sensitive. They're not meant to be like, they're not meant to have people like poking and prodding in them. So what they did is the GPIO expander goes through now the RP1, and that's used as like as a south bridge. It's used as an IO expander, but it's like a very fast I expander. I guess probably uses PCIe. I'm not sure, 100% sure, but it's a very fast communication bandwidth between these two chips to provide the GPIO support. And that makes sense. This is running at a couple gigahertz. Yeah, it's going at probably a couple gigahertz. You just need a couple hundred kilohertz for the IO speeds. Maybe SPI has like a couple megahertz. And you want to have compatibility with all the old hats and the tutorials. And you never know, like this, I haven't, looked too much into this chip, but maybe there's analog inputs, maybe there's more PWM outputs, maybe it has better NeoPixel support. That'd be really sweet because for the previous Raspberry Pis, we had to abuse the DMA, PWM, or SPI peripherals to fake out using NeoPixels, and it works, but it's really finicky. And you have to use only a certain number of pins, and you can't use like SPI, or you can't use audio output. So it'd be really nice to have that support. Oh, another fun thing is there's this button and an on-off LED. So if you turn it off, it turns red to let you know it's off, and then you can turn it back on. So let me reattach this IO helper friend, and then you press the button to turn it on, which is nice. You don't have to unplug and replug. And then we'll just quickly go to the computer, and I'll show some of the stuff I've been playing with on it. Hopefully this will come up. It is a live demo, but okay. So the biggest thing that I think is going to bump into people, and I was talking to Mr. Ladyada about this today, is we're now required to run Bookworm or greater for Pi 5 support. And Debbie and Bookworm made a decision. Good decision, bad decision. I'm not making any judgment, but it's a decision that you can no longer install Raspberry Pi packages into the system with pip. So like normally, let's say I want to use the HT20, and it's like a temperature humidity sensor. And I want to install it with, Blinka. I would do something like this. Okay, cool. Sudo pip and install it, and you install it to root. And the reason we use sudo is because for a lot of the GPIO and NeoPixel access, you have to have root, so you might as well just install it system wide. So it's like, la, 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 let's just like paste this here, and you press return, and it's like, and you can't do this. So the bookworm, look, again, bad, good, decision made. A lot of people do install or change package versions and kind of mess up their system. Python, like XKCD made fun of this, because especially on Macs with Brew versus like the internal Python, Python 2 versus Python 3, giving people the ability to change the system Python packages is like iffy. We've basically gotten away with it because it's a Raspberry Pi. Like, who cares if it gets messed up? Like, you just reinstall, or you work around it. But the new method that is required by Bookworm and Python, and you'll notice that like the Raspberry Pi Foundation is just like, we did not make this decision. If you go to this URL, they're like, you can tell that they're like preparing for this, because every single tutorial online that uses Python is like pip install, and you can't use pip install anymore. Instead, you either have to use the system-wide apt, or you have to create a virtual environment. And it's like, they explain how to do it. But basically you would have a venv. So I'm not going to go to the details of having environment, but you can see here I already made an environment. And when you launch the environment, in env, you have, binaries, so you can do env. Sorry, I'll go back up to this thing. Instead of sudo pip3 install, you do sudo env bin pip3 install, and then you can install it. So all these packages are installed into the environment, although I don't know exactly where. Yeah, they're like in one of these folders. Yeah, into like envlib, lib Python 3 site packages. So this is where, I installed Blinka. This is where it lives now. It doesn't live in user bin or in Etsy or, wherever you would have your Python, installation. So, the good news is that all the, also, by the way, oops, sorry. Another thing that is still we're gonna have to get working is envbin Python 3. Sorry. I2C works as is because I2C goes through the kernel using, the two-wire interface. And so if you do like I2C detect Y1, you can see I have the sensor plugged in. It's on address 38. GPIO, for GPIO access, we've been using rpi.gpio, which is like the ancient but traditional way of doing GPIO access, which has been superseded by GPIO 0. But again, everyone's been using rpi.gpio. Because the chip has changed, and you no longer, I think, I actually don't know how you do low-level GPIO, but you can no longer memory map into the same location. The rpi GPIO library is going to have to get updated as well, because right now it doesn't work. So it's not a big deal. I think once the Pi 5 comes out, hopefully the folks who work on rpi.gpio will fix it. So that's the second thing that doesn't work quite yet. But the good news is that if I just comment out the GPIO part and then I run the test, I2C and SPI works. Oh, sorry. See, it's like I'm going to keep typing Python 3. HT, the temperature and humidity sensor works fine. So, the overall I2C does work. So that's like a plus. I don't know exactly what I'm going to do about the environment thing. They're not wrong. That you probably should just use an environment. I'm really tempted to update our tutorials and just say, look, when you install Blinka, it'll add to your Python path and your path envbin. Like it'll create in your home directory like a Python env called like, Blinka env or whatever, or pyenv, and it will, in your bash.profile, it will set up the Python environment and set up your path so that you can just type in pip3 and Python 3, because I think people are, I think that there's like 10 years of Python tutorials that are not going to work immediately. And we're going to have to train like 20 million Raspberry Pi users that they have to change how they do Python. And I understand why the decision was made. I just am like, oh, wow, that's a lot of tutorials that we're going to have to update. But I've done it. I've done 460 revisions. And Mr. Ladyada has sent out 200,000 emails, and we have updated all of our guides before, so we will probably do it again. So that's the Raspberry Pi 5 update. So it's something to watch for. If you get your Pi 5 and you're, in the next week or two, read up about Python environments, especially if you're doing Blinka or Python on hardware. Okay, so that's my update for Raspberry Pi 5. So let's go straight to the great search.
Where in the world is that part I need? The great search with DigiKey.
The Great Search brought to you by DigiKey and Adafruit. Thank you, DigiKey. This is a time of the week when Ladyada uses her power of engineering to help you. Yes, you find the things that you are looking for on digikey.com. Ladyada, what are you looking for this week?
Okay, so on the new Raspberry Pi 5, which I just got today, there are these cool new extra connectors. Can you go to the overhead real fast? And I'll just point them out. So this connector here is the one I'm most interested in. It's called UART. So traditionally, if you wanted to connect to the UART, the debug port of a Raspberry Pi, you'd connect to like these two pins up here, like power, ground, RX, and TX. And you'd use something like this. So we'll use this USB console cable, and you would plug these, into the GPIO, and then you could get to the console. Which is really helpful if you're running like a headless setup. You don't know the SSH, maybe it's not on the network. You want to just like have root access immediately. The good news is now that there is this new RP1 chip, I'm assuming, I'm still experimenting. I just got this like working yesterday, that this is a separate connection to the hardware UART for console than the pins over here, which would be connected to the hardware serial port. And the hardware serial port is how you'd connect stuff like GPSs. And before, you could only have one or the other. You could either have a console or you could have a GPS. You couldn't have both. But now I'm pretty sure you can have both because the UART is on a separate connector. So I would like to make a little adapter cable that takes this from the old style Pi into this. But this has actually not been, the documentation for this connector hasn't been released that I could find. So I thought I'd show how you could determine what the connector is. Now, I kind of know what it is because I just use these connectors all the time. But what if you don't know? What if you're like, I have never seen this before? A really good skill on how to reverse engineer and determine what connector it is. So first I'm going to turn off the Pi. So yeah, I love that on off button. You only use it like 10 times and already I'm like, this is my number one fan. I mean, this is the fan connector over here. So that's the number one fan, but this number two fan. Okay, so unplug this. So let's get in here and let's zoom. Okay, so what we're looking at here is a 3-pin connector. It's vertical and it's definitely not 0.1 inch spacing, but we don't know what the spacing is. And it's got this tan connector, and you see there's these little nubs on the side. So we want to find the cable that connects to it. But the easiest way to get the cable is actually to first find out the connector is, because it's like way easier to identify connectors by image than cables, especially because like there's often the shadowing isn't very clear. Whereas here it's like you can see the outline very nicely. So the first thing you want to do is find out the connector pitch. So what I do is, first off, most connectors are in millimeter pitch. Not always. Big ones aren't, but small ones tend to be in millimeter. So what we want to do is we want to measure between the centers of the two farthest pins. Now you're probably wondering, well, why don't I want to measure from like two pins close to each other? The reason is it's really hard to like, you're like, oh, is it like 91 or is it like 1.25? The difference in pitches can be like really small, and you want to average that in clarity over a larger number, because if you're like having difficulty getting to the center of the two pins, at least you have a bunch of pins to divide by. So, okay, so if you have error, the error divides out. So let's see, let's try to get, you can also, no, this is definitely going to be the easiest. So I want to get kind of in the center of the two, and I'm going to do this by looking above. Hold on. Actually, turns out you can't look at a screen while measuring connector pitch. Okay, that's pretty close. Okay, so I got 1.91. And just so you know, like connector pitches aren't going to, they can be like 0.95, but they're pretty much never. It's always on the quarter millimeter. So it's like 1 millimeter, 1.25, 1.5, 2 millimeters, stuff like that. So probably my hands aren't as steady. It's 2 millimeters between two pins. So it's 1 millimeter pitch. So let's go to the DigiKey site. So we can go back to the computer. And let's look for connector. I know you're like, that's kind of vague, but we can then look at images to see which one is the closest. So we want something that's closest to this. It's pins, and it's a rectangular connector. So let's scroll down, look at some images. Yeah, I mean, like this isn't the connector, but like that's the idea we've got. Something like this, right? But we want a surface mount version. So let's start paring it down. So first up, we want active, and it has one row with 3 pins, and that should cut down like a ton. And the mating, so I actually do, I usually do the number of rows first, or like the number of pins, the number of rows first, because then I can see like what pitch is available. And like I said, if I had measured 1.8 millimeters between the 2 pins and 0.9 was available, I'd be like, well, maybe that's a possibility, 0.035 inches. But given that the only options I've got are either 0.8, 1, or 1.2 or 1.25, it's definitely going to be 1 millimeter pitch. So, it's just calipers is really hard to get perfect. You're going to be plus or minus like 10%. So just be flexible. Don't be like, oh, it has to be exact. Okay. And then, all right. So that already pared down a lot. I think it went from 500,000 results to 85. So that's great. Okay. And then I want surface mount and, upward. Right angle is actually across the board, and non-right angle is pointing straight up. So that's good. Let's do that. Apply. And then let's search for, normally stocking. Get rid of some of the weird connectors. And then shrouding. So that's another thing. So, some connectors, I think there's a lot here. Like this is unshrouded. There's nothing going around it. And there's also sometimes connectors that have only like partial shrouding, but we have a shrouded connector, so we might as well select that. Okay, so apply. All right, great. So it's only like 20 options now. So now we can actually look and see which one is the most similar. So let's actually look over. Sorry, can you go back to the computer overhead real fast so we can just take a look at this connector? All right, so it's a 10 connector, and it's got these little ears, and it's got like these 3 contacts, and there's these like kind of metal bits here. So we have 20 options. It's actually not that bad. Can we go back to the computer? So there's a couple good looking ones. So this one, let's take a look at this one. I like the 360. So this one, it's close, but it doesn't have the metal bits on the side like the other one does. So that's not it. And let's look at this one from Molex. Let's look at the data sheet because there's only one image. This one looks like it has a little notch, which this connector doesn't have a notch. Looks pretty similar. It also doesn't have the little ears. And also it looks way taller than this contact. This actually, let's measure the depth. It's not a bad idea. I should have done that to start. So the depth is 4 millimeters. So, sorry, the height of it should have been 4 millimeters, which this is not, this is 5.1, 5.4. So this is not right either. I don't know if they have the height. Oh, insulation height, they do. So let me actually, let me pare down by the insulation height. So like 4, maybe I'm off, but it's about 4 millimeters. Let's see how that does. Okay, so what we've got left, this doesn't look too bad. TE, very similar, but this one is definitely the closest match. So let's look at the 360. Okay. Okay, so you can see it's got those ears, and it's got the metal on the side. It's even got the little dots. So this is it. This is the connector. Yay. Okay, we found it. So it's this, the BM03B SRSS. So now we know the connector. So now if you want to match with the cable, oftentimes at the bottom here, you can see associated products. And these are items that go with or mate with this connector. Sometimes they even have, there's a lot of information here, but yeah, mating. Sometimes they have like, you know, mating contacts. Yeah, here you go, mating products. So this is like if you want to build your own cables, this is like the matching connector, but there are cables available. So let's check this out. So yeah, so this cable, you can get this cable, cut it in half, and then I can splice it onto the cable I've got here to make a UART cable for the Raspberry Pi. And there, it's also available. This is a new thing, alternate lengths. It's kind of neat. So if you don't have, you know, if happened they didn't have in stock the 12-inch, or if I don't want the 12-inch, I can get the 4-inch version, which, yeah, you can see the little ear sticking out here. And they've got 999 in stock. So this is my pick for the great search to connect to the UART port on your Raspberry Pi 5.
And that's a great search.
Where in the world is that part I need? The great search with DigiKey.
All right, and that is our show for this evening. Thank you so much, everybody. We'll be seeing you throughout the week this week. Lots of cool and interesting things ahead, and please continue to make and share things together. Everyone makes something. There's a lot going on planet Earth, but we can come together and make things and share knowledge and try to build some bridges together. So let's do it.
Okay. All right. Have a
Bye.
good weekend and a good week, everybody.